Hi there students, we're going to do chapter 5 right now, which is called chemical bonds. This is also a very simple chapter. This chapter helps you form a basic understanding of the differences between atoms and an ion. Okay, so students, the first thing I'd like to talk about is the difference between an atom and an ion. And for this, I'm going to use an example. For example, let's take sodium. Okay, sodium, talk about the atom and the ion. Now, when we look at the periodic table, sodium has a proton number of 11. That means it has 11 protons, 11 electrons, and sodium has a nucleon number of 23, meaning it has 23 minus 11, that is 12 neutrons. Okay? So, when we find the electronic configuration of sodium atom, we look at the electrons. So, we have an arrangement of 2.8.1, right students? Now, we've mentioned before that for sodium to become stable, it should lose the last electron in its valence shell, right guys? So, when that happens, sodium loses the one electron and it gains a charge, okay? Now, this charge for sodium is called Na plus. The plus sign because sodium has lost the one electron. If sodium or another element were to gain an electron, it would be a minus sign, okay? So, this is the difference between an atom and an ion. In an atom, when you talk about sodium atom, the symbol will be Na, just Na, and the value of its proton, electron and neutron will be obtained from the periodic table. Whereas when you talk about sodium ion, it is called Na plus because an ion is already stable. It's already achieved octet electronic configuration. So when the sodium atom loses this one electron, its electronic configuration becomes 2.8. This is the electronic configuration of sodium atom. Now, when we look at this, what is the number of protons, electrons and neutrons for sodium ion? The number of protons will remain unchanged, right? Because when we talk about an ion, the only thing that increases or decreases is the electrons, because the electrons are involved in the formation of an ion. So sodium will still have 11 protons, sodium will still have 12 neutrons. You see the nucleon number doesn't change, it's still 23. The only thing that changes is the number of electrons. Instead of being the same as the proton, it's now gone down by 1, so you have 10 electrons. Are you able to understand this, guys? Let's do one more example, okay? The point here is to stress the difference between the words atom and the words ion, okay? Now, if I talk about an element, say sulfur, okay, so we'll talk about sulfur atom and we'll talk about sulfur ion. So first of all, the important thing to know is that sulfur has an electronic configuration of 2.8.6. okay, this is sulfur as an atom or as a molecule, because sulfur has 16 protons and I believe sulfur has 32 as its nucleon number, 16 as its proton number and 32 as its nucleon number. Let me just check that again, guys. Sulfur nucleon number. Sulfur has no. Okay, now nucleon number equals 32. Okay, so when you look at this, sulfur has 16 protons, 16 electrons, because proton and electrons for the atom is the same, and the nucleons will be 32 minus 16, which is also 16. The electronic configuration is 2.8.6. Now, what will the electronic configuration be for the ion of sulfur? Remember, when we form an ion, we want to make it stable. To become stable, it needs to have 8 electrons in the last shell. So, this sulfur atom should gain 2 electrons, not lose 6, but gain 2 to become stable. So, it becomes 2.8.8. What happens to sulfur when it gains 2 electrons? The ion is S2 minus. 2 because it's gained 2 electrons, and the minus sign because it is gaining electrons. If you lose electrons, it's a positive sign. When you gain electrons, it's a negative sign. Now, what is the number of protons, electrons, and neutrons for sulfur ion? Remember guys, proton and neutron will be the same for an ion as in the atom. So we'll still have 16 protons, we will still have 16 neutrons. The only thing changing is the number of electrons. There's a 2 minus here. So will the original number of electrons be subtracted by 2 or added by 2? Think students, we are talking about electrons. The more negative, the more it is. So it's plus 2 electrons. 16 plus 2 is 18. 18 electrons. So this is the very important concept, students, to be able to differentiate between the words atom or molecule and the word ion. Remember, ion is stable, okay? It's already formed a stable electronic configuration. Now, I'm going to talk about a few examples of compounds, how we form compounds. We did this before in chapter 3 in chemical formulae, but let's just go over it again. So, how do I form a compound with aluminium oxide? Aluminium oxide. Students, when we form a compound, this is where we take our ion form. Okay, we take the ion form of each element and then we combine them. So let's start with aluminium. Aluminium as a metal, as an atom, has an electronic configuration of 2.8.3 because it has 13 electrons. Okay, so for it to become stable, to form an ion, it must lose 3 electrons. Once it loses 3 electrons, it becomes Al. Because it's lost 3 electrons, 3 plus. What about oxide? Oxide is simply oxygen. Oxygen as in the molecule state is 2.6 because it has 8 electrons. What should it do to become stable? It needs to gain 2 electrons. So O2 minus. Now when we are forming the compound, we cross multiply and we get Al2O3. This is how we form aluminium oxide. Now, another example, iron 3 oxide. Now, question is, why does iron have the 3 here? This is because, if you think about it, like copper, iron is a transition metal. It's present between groups 3 and 12. It has many oxidation numbers because that's a special characteristic of transition elements, right? Exhibits different oxidation numbers. Iron can be iron 2 oxide or iron 3 oxide. So the fact that it's iron 3 means that it's going to be Fe3 plus. You know it's going to be plus because iron is a metal. All metals are positive and are plus. All non-metals are negative in the ion form. Oxide, we talked about it just now, is O2 minus. Cross multiply, Fe2O3. So this is how you form compounds. Let's do another one. Tin 4 oxide. Tin 4 oxide. Now, tin is the chemical formula for tin is SN. and 4 meaning because tin is a metal, so it's 4 plus, oxide is O2 minus, so you would cross it again, but guess what, you can actually factorize these two, or you can cancel them because there's a common factor of 2. You get that, guys? Now you cross multiply and you get SN1O2. Alright guys, lead 2 sulfide, let's do that one. Lead 2 sulfide. Lead is Pb2 plus, sulfide is sulfur, so let's think. Sulfur is 2.8.6. To become an ion, it needs to gain 2 electrons, so it's S2 minus. Now you have a 2 and a 2, you can cancel them out, so all you get is PbS. Magnesium carbonate. Now students, I know these are a lot of examples, but this is the time to really, make you an expert at chemistry, especially in this part. Magnesium is Mg2 plus, okay? At this point, guys, you don't have to, individually prove how to get Mg2 plus. You already know, it's in your head, Mg2 plus. Carbonate is CO3 2 minus. This is in chapter 3 where I explained nitrate, carbonate, sulfate, phosphate. It's hard to understand it, so you should memorize it, guys, honestly. Now the 2 and the 2 on top can cancel each other, so you cross multiply from the top and top, bottom and bottom. So there's a 1 here that comes down, Mg, and this 1 over here comes down, so you don't have to write it down. You get MgCO3. Copper 2 carbonate. Same thing, copper is Cu2 plus, carbonate is CO3 2 minus, cancel, CuCO3. One more, calcium carbonate. Calcium is Ca2 plus, carbonate is CO3 2 minus, cancel, CaCO3. So this is how you form these compounds. Now, quick thing I want to mention, guys, every compound that we form so far involves a metal and a non-metal, involves a positive ion and a negative ion. Now, this chapter is called chemical bonds, right? So we are going to talk about the 2 types of bonds called ionic bonds and covalent bonds. So before we get into this, the book always likes to talk about inert gases. Inert gases are noble gases, which are group 18 elements. Do group 18 elements form ionic bonds or do they form covalent bonds? Guess what, students? Group 18 elements form no bonds. The reason? Because remember, chemically inert, chemically unreactive, they already have 8 electrons in the valence shell. Except for helium, it has 2 electrons in the valence shell. So they've all formed octet electronic configuration. They don't need to take part in a bond. They don't need to become stable. They already are. So group 18 elements are never involved in forming ionic bonds or covalent bonds. Okay. So how do we form these type of bonds? The first thing you need to know is an ionic bond is formed between a metal and a non-metal. A covalent bond is formed between 2 non-metals, or more actually. It can be more, but mostly 2 non-metals. How does this take place, guys? For an ionic bond, there is a transfer of electrons. When I say transfer of electrons, I mean there could be a gain of electrons or a loss of electrons. So we'll see all this whenever we do examples. Covalent bonds is the sharing of electrons. Now, what does this mean? Don't worry, students, just try to know what I'm talking about right now. Once you do the examples, it will all make sense, okay? Now, ionic bonds are bonds that have a strong electrostatic force, okay? That is how ionic bonds are held. So, ionic bonds are held together by strong electrostatic forces. Okay, what does this mean? Again, don't worry about it, guys. We'll come to this in a second. Okay, so an example of an ionic bond. Just think, ionic bond is between metal and a non-metal. So you can form any bonds from a metal and a non-metal, and you'll have an ionic bond. Let me take a simple example. Sodium chloride. Sodium chloride or salt, that's the common name, is formed from an ion of sodium, Na plus, and chlorine, Cl minus. We end up getting NaCl. Okay. Now, for covalent bonds, we'll come to that in the next part of the next video. This video, I just want to focus on ionic bonds. Okay, guys. So, I'm just going to read what the textbook says. An ionic bond is normally formed between a metal atom and a non-metal atom. So we talked about this to form an ionic compound. This bond is formed through the transfer of electrons. We talked about this as well. The transfer involves the loss or gain of electrons. Remember, when we form bonds, we only deal with electrons, not protons or neutrons. Then, the metal atom loses its valence electrons to achieve a stable octet electron arrangement. We talked about this too. The non-metal will gain an electron or gain 2 electrons, or 3. The metal will lose electrons or lose 2 electrons or lose 3 electrons, depending. And remember, students, when you form bonds, you only deal with the valence shell, which is the last shell. The valence shell has valence electrons, which are the electrons in the last shell. We don't deal with any of the other shells, okay? So, the metal will become the positive ion, the non-metal will become the negative ion. And there are terms for this, okay? A positive ion is called cation. The negative ion is called an anion. Now, we'll see cations and anions a lot in chapter 6, electrolysis. So, it's good if we start to understand them now. Okay. So, I'm going to do a few more formations of ionic compounds for you guys. Aluminium fluoride. Aluminium is Al and electronic configuration is 2.8.3. So, for it to become an ion, it needs to lose 3 electrons. So, it's Al3 plus. Fluoride is 2.7. So, it needs to gain an electron to become stable. So, F minus. When it forms a compound, AlF3. What about barium chloride? Barium chloride. Barium is Ba2 plus. How do we know it's Ba2 plus? Let's look at the periodic table. If it falls in the same group as magnesium in group 2, it's going to be 2 plus. So just notice this, guys. Everything in group 1 is plus 1. Everything in group 2 is plus 2. Everything in group 3 is plus 3. Don't worry about group 4. Everything in group 5 is minus 3. Everything in group 6 is 2 minus, in group 17, in group 16 is 2 minus, in group 17 is 1 minus, and group 18 there is no sign because it's noble gases that are stable. So now we do barium chloride. Barium is Ba2 plus, chloride is Cl minus, so we get BaCl2. Calcium oxide. Calcium is Ca2 plus, oxide is O2 minus, we get CaO. Magnesium nitride. Magnesium is Mg2 plus, nitride is N3 minus. So what do we get? Mg3 N2. And the last one, sodium sulfide. Sodium is Na plus, sulfide is S2 minus, you get Na2S. Alright guys, so now you know how to make many types of ionic compounds. So let's talk about what an ion is. We know there are positive ions called cations. We know there are negative ions called anions. What is the definition of an ion though? An ion is a positively charged or a positively or a negatively charged particle. I use the word particle because particles are either atoms or molecules or ions. So an ion is a positively or negatively charged particle. An ion is formed from an atom or a molecule when the atom or the molecule forms a stable electronic configuration, meaning it can either gain electrons or either lose electrons. Okay guys, so we already said that metals will lose electrons, non-metals will gain electrons. So let's look at how this works. Okay, we'll break down ionic compound into the basics, then we start to write down the formulas and we draw them. So formation of sodium chloride. Okay, sodium is in the atom stage is 2.8.1. Chlorine is always a gas. In its molecule stage it's 2.8.7. So for sodium, for it to become an ion, it will lose an electron and it will become sodium metal, becomes a sodium ion, Na plus, and because we've put a plus over here, we need to add one electron. What does this mean? This one sodium ion, the extra ion here, plus this one electron gives us sodium metal. How is the equation for chlorine? It's the opposite. The plus sign is on the left because it's gaining an electron. So chlorine plus one electron gives us the chlorine ion. Do you see the difference, guys? All right, so let's draw this out, okay? Whenever we do ionic bonds, we have to write the equation. These equations are called ionic equations, okay? These are different from chemical equations. Remember I told you guys that when we do chemical equations, we don't have the plus sign or minus sign, we don't use any ions. In a chemical equation, we use the atoms or the molecules. Only when you have an ionic equation, you use the plus or minus symbol to show the ions. So I'm going to draw this out for you guys. Sodium, which is 2.8.1, four, 5, 6, 7, 8.1, okay, becomes And whenever it forms an ion, you have to put it in this square bracket. Sodium, it's lost one electron, so 2.8.1 becomes 2.8. 3, 4, 5, 6, 7, 8 with the plus sign. Does that make sense, guys? Now, for chlorine on the other hand, chlorine as a molecule is 2.8.7. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 becomes chloride ion. When it becomes an ion, you put it in the square bracket, and since it gains an electron from 2.8.7, it becomes 2.8.8. 1, 2, 3, 4, 5, 6, 7, 8. And one more. 1, 2, 3, 4, 5, 6, 7, 8. And the minus sign. Alright, guys. So we're now going to form more and more ionic compounds. I just wanted to give you guys this video as a basic. In the next video, we're going to form more ionic compounds. So stay tuned, guys. Thank you.